Assalamualaikum and salam sejahtera. Now we continue our lecture from the previous lecture, that is bypass RS. Now we go on to the next lecture, which is common source unbypass RS. So as you can see, the circuit is almost the same as bypass RS. Here you can see it uses the MOSFET configuration, but actually for AC analysis for FET, your AC analysis will be the same also for other type of configuration, Jfet for example. So here the first thing you need to do is to replace all the capacitor with short circuit and set DC source to 0. So here VDD will be equals to 0, so it will be grounded, and capacitor C1 and C2 will be short circuit as in this figure over here. So you need to redraw this circuit. After you have redraw the circuit, you will get this kind of circuit over here. So as you can see, if you want to look at the input impedance, so you have to look at this side. Here is the arrow, and if you want to look at the output side, so this is the arrow for the output impedance. So after you have redrawn the circuit, substitute the AC small signal into the circuit. That is by substituting this symbol into AC small signal circuit. So you will have this kind of circuit. This is the AC small signal equivalent circuit after you have substitute the FET transistor model here. So let us analyze the small signal circuit. Okay. The first one is to find the input impedance. So input impedance is by looking at this side. So input impedance is equals to RG. For output impedance, you need to set Vin equals to 0. After you have set Vin equal to 0, what will happen? The input circuit will gone, and we only have the output circuit. Okay. Previously for bypass RS, you will see that in order to find the output impedance, there will be no GMVGS over here. But in this case, for unbypass RS, there is external voltage applied to the output. So from that criteria, you can see that there is a current flow into the output circuit over here. So when there is current flowing into the circuit, so what will happen? There is a voltage will occur at the resistance RS. Okay, all the resistance will have a voltage. So this voltage across RS is equal to the VGS, voltage of VGS. Although the input is 0, but still due to the external voltage at the output, you still will have the value of VGS. So here, as you can see, the VGS voltage value is from the input side is plus and minus. But for the output side, the polarity will be opposite. So this is the minus at the source terminal, and this will be plus. So VGS, the voltage VRS will be equal to minus VGS. Alright, so let us look at the analysis in order to find the output impedance. Firstly, you need to write down the output voltage equation. So Vout equals to minus IDRD. That is the first equation over here. So as you can see here, the current that flow through RD, capital RD over here is going upward. So if you draw a loop over here, that is the output side, you can see that it will be minus V out plus minus ID RD and plus uh, sign is over here. So minus V out plus IDRD equals to 0, because the current, due to the current that move upward, so this terminal over here will be positive sign and this will be negative sign. So if your loop is in anti-clockwise position, so your loop equation will be minus V out and plus IDRD equals to 0. So from there you will get V out equals to minus ID RD as in equation 1. So for VGS equals to minus ID RD for equation 2 over here, this equation is come from the circuit over here. Okay, so VGS equals to minus ID RS. Alright, so from here you will have two equations, V out and also VGS. Okay, now we look at the voltage here, okay, at the small letter RD. So the voltage here is actually the different voltage between this point and this point. So this point, this node is actually the output node and this is the source node. So the different voltage here is equal to this equation. You can see that IRDS is the current that flow through this small letter RD multiplied by RD equals to V out plus VGS. So here you will get the equation will become minus IDRD and then minus IDRS. This equation comes from the equation 1 and equation 2. Okay, so after you have this equation, and then you can simplify the equation, you will get minus ID multiplied by RD plus RS divided by R small letter RD. So this is equation number 3. And then KCL at node drain. So if you look here, if you want to do KCL at this node, you will see that the first input or the incoming current is I0 plus ID equal to current leaving the node, that is GM VGS, and current that flow through RD, that is IRD. This is a small letter RD, okay, current that flow here. So this is the dependent current. So the dependent current here is equal to GM VGS. So here you can see that from KCL at node drain, you will get I0 or I out plus ID equals to IRD plus GM VGS. Okay, now you have to substitute. Here you find that IRDS equals to equation number 3. So you substitute this equation into this equation. Okay, so you will get I out. Okay, first of all, you need to move ID to the other side. So you will get I out equals to IRD plus GMVGS minus ID. So then you substitute the equation here, equation 3 here, into the current equation over here. So I out equals to minus ID multiplied by RD plus RS over RD, that is from equation 3, plus GM multiplied by minus IDRS, this is the equation from number 2 here, and then minus ID. So simplify this equation, you will get I out equals to minus ID multiplied by 1 plus GMRS plus RD plus RS over RD, small RD. Okay, in order to find Z out, so therefore Z out equals to V out divided by I out, and it is equals to minus ID RD. This is the comes from the equation number 1 here. So divide by I out, divide by I out from this equation here. So after you have simplified, that is by cancelling minus ID and minus ID over here, you will get equals to RD divided by 1 plus GMRS plus fraction of RD plus RS over RD. Okay, there is some cases where RD is greater than or equal to 10 RD plus RS. So in this case, we can ignore the effect of RD, but you need to test this first, this formula first, in order for you to ignore the effect of RD. If it is satisfied, then you can say that Z out equals to RD over 1 plus GM RS. Okay, now we go on to the voltage gain for unbypass RS. Alright, so the formula for voltage gain is AV equals to V out. Let me do some writing here. Let's see. So, sorry, my writing is not so good because I'm using mouse. AV equal to V out over V in. Okay. So this is V in equals to VGS plus VRS. This is at the input, sorry, this is at the input loop. Okay, so you have to refer to the input loop. Okay, so here you can see this is the input loop. Look at my cursor over here. This is at the input loop. So at the input, the equation is minus V in plus VGS and then plus VRS equal to 0. Okay, minus V in plus VGS and then plus VRS equal to 0. So from here you can get this equation. Okay, so okay, so this is the at the input loop. So VGS equals to V in minus IDRS. This actually comes from this equation over here, but for VRS you have to change it, or you have to substitute for the equation minus IDRS. So from there you move the VRS over the other side and you get VGS equals to V in minus IDRS. So the second equation is IRD multiplied by small letter RS. Okay, so this actually is equal to small RD. Okay, I'm sorry. Let me try again. This equals to RD RD, small letter RD. Okay, so you guys need to take a note and change this to small letter RD. So this equation comes from the at the output terminal over here. Okay, sorry. Okay, you have V out plus VGS and then equals to IRD RD. So this is the output. Okay, minus V out plus IDRD minus VGS equals to 0. Okay, let me do it again. Minus V out plus IDRD. This is actually plus and minus the polarity here. The polarity here for voltage over here, you have to look at this minus VGS. Okay, so from there you will get this equation over here. Okay, so okay, so sorry, so this is the equation that you will get. So this is the second equation. So V out equals to minus, this is actually minus VRS. So you have to use this voltage across RS over here. Okay, so this is ID RS. So this is actually for this terminal here, this is plus, minus, plus, minus. So minus V out plus IDRD plus VRS equals to 0. From there, you can get this equation. Okay, after you have moved VRS and also RS to the other side. So that is equation number 2. So V out equals to minus IDRD. That is from the output loop. This is the loop. V out equals to minus IDRD. Okay, this is plus, this is minus and this is plus. Okay, so when you do a loop here, you will get minus V out and then minus IDRD equals to 0. Okay, so from there you will get V out equals to minus IDRD. That is equation number 3. And for VRS equals to IDRS. Okay, so VRS equals to IDRS. Okay, KCL at node drain. This is equation number 4. Okay, so now we go on to the KCL at node drain. You'll get ID equals to GM VGS plus IRD. So this ID and this equation is actually from here. This node over here. So the current entering the node, that is GM VGS and also IRD equals to ID. So ID equals to GM VGS plus IRD. From there you can get IRD. You know that IRD equals to this equation. Remember that you need to change this, okay, to RD. Okay, so okay, ID equals to GM VGS plus IRD, so equal to GM VGS plus V out minus VRS over this one is RD. Okay, and then substitute 1, 3, and 4. This is 1, 3, and 4 into this equation over here. So 1 will substitute to VGS, and then 3 V out here, you have to substitute to this V out over here, and number 4 VRS here, you substitute it, so you will get this equation here. So ID equals to GM, VGS is equals to V in minus IDRS, and then plus, and then this is the V out minus VRS over RS. So from there you can simply simplify the equation. After you have simplified the equation, you will get ID equals to GM V in over 1 plus GM RS plus RD plus RS over small letter RD. Okay, so substitute 5 into 3. So this equation number 5, you substitute this equation to 3 in order for you to get AV equal to V out over V in. So after you substitute this into 3, you will get the equation here. V out equals to minus RD multiplied by ID. This is ID. Okay, and then AV equals to V out over V in equals to minus, after you have simplified this equation, you will get equals to minus GMRD over 1 plus GMRS plus RD plus RS over small letter RD. So if this condition satisfied, then AV equals to minus GMRD over 1 plus GMRS. Alright, so I think that is for today lecture for Unbypass RS. So we will continue for the next lecture in other video. So that is for the common drain, but right now we just focus on Unbypass RS. If you have any question, just message or you can comment in the Google Classroom. Thank you very much. Assalamualaikum dan salam sejahtera. Bye.